What's up everyone, it's Mr. Lang, and in this video I'm going to be teaching you how to graph systems of linear inequalities. Now in class we already learned how to do single linear inequalities. That's when we have lines, they can be solid or dashed, and we shade. Alright, now we're going to be basically doing two of these on the same graph and figuring out the solution area. So you need the sheet that I handed out in class to do these. It should be a front and a back with 4 problems. So let's get started. Number 1, it says graph and label the solution set of the system. And I'll come back to what that set means. And when we're graphing this, we want to make sure the y is isolated and it's in that y equals mx plus b form. Now I know these are inequalities, so you're not going to have equal signs. You're going to have, greater thans, less thans, greater than or equal to, less than or equal to. But the form should be the same. So with this first one, it looks like we're good. We've got the y isolated, and it's mx plus b. Same thing here, y, and then mx plus b. So just to be careful here as I'm graphing, I'm going to label what my m and my b are for each line before I graph. So this first one, it looks like my m is a negative 4, so I'm going to say my m is a negative 4 over 1, and my b is the 5. So let's graph this line first. So I'm going to start with the 5 as my y-intercept, and my slope is negative 4 over 1, so I'm going to go down 4 to the right 1, down 4 to the right 1, fit as many of these as I can on, and I'm even going to go backwards 1. Now before I draw my line, I'm going to check to make sure, is it going to be a dashed line or is it going to be solid? And since it's greater than with no line underneath, I know it's going to be dashed or dotted. So I'm going to use that, and make sure you use a straight edge with this. These have to be super neat. Oops. And when you draw the line, make sure you got the arrowheads on both and you extend it out kind of past the graph. But it's also important you label it. And when you label it, remember you have to label with the equal sign because you're actually labeling the line, not the inequality. So I'm going to label this y equals negative 4x plus 5. Alright, we're going to do the same thing with the other line here. I'm going to switch to red dots here. The m is a 1, so I'm going to say it's 1 over 1, and the b is the negative 2. Now notice with this first one, I didn't shade anything yet. I always wait to shade until I've got both lines ready to go. So anyway, the b is a negative 2, and the slope is 1 over 1. So I'm going to go up 1 to the right 1 and keep doing this. And that's probably good there. And I'm going to go a few back this way, and that's probably good that way, as long as you get enough where you can see them cross. Now this one is going to be a solid line because it's got the line underneath for the equals. So I'm going to use my solid line. Oops. Okay. And again, I gotta label this one. This is my y equals x minus 2. Alright, so I've got both of these labeled, ready to go. Now we gotta shade. So I'm gonna start with the line we started with first here, which is y is greater than negative 4x plus 5. I'm gonna switch back to blue. And greater than means bigger than. So it's kind of hard to tell sometimes, well, am I going to shade this way with it or this way with it? And I try to imagine this line, this dashed line here, being like a hill. And if you were to think, well, if this was a hill, where would the dirt be? All right, and the dirt would have to be down here, and the sky would be up here. And I think, the sky is above. So when we're doing greater than, I'm going to shade above where the sky would be on this hill. So I'm going to shade kind of perpendicular lines like this. Try to keep it as neat as possible. Remember, I say shade, but we're not actually like scribbling in anything. Keep it nice and neat. All right, and this one is less than or equal to this red line here. Now, less than means less than down, so we're going to be going down where the dirt would be here. And I'm going to shade this one with red. Now, if you don't have colored pencils or anything like that, that's fine. I'm just doing it to illustrate where we can see the solution area. All right, so we've got them both shaded. Now, what we want to look for is where the area on this graph where both are shaded. And right up here is just the blue, right down here is just the red, but you can see kind of the waffle pattern here. So this is my solution area, and what I like to do is, let's get my highlighter. It's this kind of triangular, kind of meets up at a point here, it goes here, and it fills in all the way here. This whole area is where I have it waffled. And I'll fill it in pretty good here. And again, if you have a highlighter, it's great to be able to do this. It makes it super easy to see. If you don't, it's not a big deal. All you really have to do is mark it, oops, with a big S. That's my graffiti S. All right. So what this means, this is the solution set. We're not finding like a specific point like with systems of equations. This point here where the lines intersect really is actually in this case not even a solution. It's any point within this area. And so I could pick, you know, this point, you know, 5, 1. I could pick, you know, something down here. I could pick any point in here and it would check with these two equations. So what we always want to do with these is check. So I'm going to pick any point in here I want, but I'm going to pick the easiest point. You know, I try to pick stuff with zeros in there. So I'm going to check. Oh, I don't know. I'll pick, if I went 10 this way and kept it at 0, 10, 0 would be a point in the solution area. So I'm going to use 10, 0. And I'm going to see if it checks. And I have to check it with both. So the first one's going to be y is greater than negative 4x plus 5. And I'm going to also check it with the other one, y is less than or equal to x minus 2. So my x is 10, my 0 is y. So 0, is that greater than negative 4 times 10 plus 5? Well, negative 4 times 10 is negative 40 plus 5. That would be negative 35. Is 0 greater than negative 35? Yes, it is. Now I'll check this one. Is 0 less than or equal to 10 minus 2? Well, 10 minus 2 is 8. And yeah, 0 is less than or equal to 8. So this checks. So that doesn't necessarily mean I did this perfectly right. All it means is that this point did check, and it's most likely that you did it right if the point you pick works. All right, and one last thing: when you're picking your checkpoint, technically you could pick a point that lies on a solid line, but you couldn't pick a point that lies on a dashed line. So I just say don't even pick any points that are on a line. Just pick one that's somewhere in this shaded area. It makes it a lot easier. All right, let's go to number 2. Number 2, we've got y is greater than 3/2 x minus 4. This one is in good form. The m, let me get my blue pen here. The m is 3/2, and the b is negative 4. This one is not isolated. It's not in that y equals mx plus b form we like, but it's close. So what I'm going to do is subtract 2x from both sides to get the y isolated. And what I'm going to get is y is greater than, no flipping or anything, negative 2x, and this is a positive 2. Now this one's good. So in this case, my m is a negative 2 over 1 for that, and the b is a positive 2. So what I want you to do here is pause, do this one yourself now that we got both of these, and then and I'll do it while you're paused here, and then you can unpause it and we'll check our answers. So again, pause it right here. Alright, let's see how you did. You should have two dashed lines. Both are greater than, so you're shading above both. Alright, and the area, the solution set is going to be this triangular area. And so I marked that with the S. Make sure of a couple things. Make sure that you've marked that big S, and make sure that you've labeled each line with an equal sign. Ooh, I goofed there. So there you go. We're going to make that an equal sign. See, I goofed too. Sometimes I forget to do that. Anyway, I checked the point 0.5, so 0.5 would be right here. All right, and I always like to pick 0 if I can, either with the X or the Y. Checked them with both and it worked. So listen, pause it here if you didn't get this and see if you can find your mistake. But we're going to move on to number 3. All right, number 3 looks nice and short, but it is actually the kind of problem that people goof on the most. So I'm going to go through this kind of quickly, but I think you'll see why people might make the mistakes. All right, the first one here, the y is isolated, so this looks good. So my slope is 1/4 because it's y equals mx. Now there is no b shown here, so what that means, it's really like a plus 0, you can think of it. So our b is 0. And for the second part here, this is x is less than or equal to negative 3. Well, there is no y. All right, this is the special case where we've got a vertical line because it's x isolated and there is no y. So it's going to be a vertical line. So the slope is really undefined. So I'm going to quickly graph these two lines. I'm going to start with the first one here, 1/4 x. So the b is 0. And I'm going to go up 1 to the right 4, up 1 to the right 4. I'm going to go backwards and backwards here. And this is a dashed line. I'm going to label it y is equal to 1/4 x. And it's strictly greater than, so I'm going to shade up. Shade above it. Now with the undefined, I'm going to graph this one with a solid line because it's less than or equal to. So I'm going to go over to the x is equal to negative 3 and draw my vertical line there. I'm going to label it x equals negative 3. And less than, in this case, you got to pick either left or right. That's what makes this one a little bit weird. So I'm going to go left because left is less than. And you can see where my solution area is here, where these both meet. It's going to be in here, just like this. And I'm going to mark it with my big S. Now, I'm running out of time here, so I'm not going to check this, but I would probably check, in this case, something like a negative 10, 0. That would be in the solution area back here. But again, I've run out of time. So I think we're pretty good. So your SIA question is to do the next question, number 4. There's nothing to do online, so don't worry about anything like that. So to get credit for your homework, just finish, obviously with the notes that we've taken, but also do number 4. Thanks for listening.